Hello, welcome to the channel. So today in this lecture, we will study about solar radiation, chapter number 3 of the book SUKHATME. So first of all, let us have a brief introduction about what is solar radiation. First of all, let us have a brief knowledge about the diameter of the Sun, Earth, and the mean distance between the Earth and the Sun. So the diameter of the Earth is approximately equal to 1.27 into 10 to the power 4 kilometer. The diameter of Sun is approximately equal to 1.39 into 10 to the power 6 kilometer, and the mean distance between Sun and the Earth is approximately equal to 1.496 into 10 to the power 8 kilometer. Okay, so I'm talking about the mean distance between the Sun and the Earth. Why mean distance? Because as we all know that the Earth revolves around the Sun in an elliptical orbit, and the distance between the Sun and the Earth is not constant. Okay, so it changes with respect to the day on the Earth. Okay, so that's why we consider the mean distance. So do remember that the mean distance between the Sun and the Earth is 1.496 into 10 to the power 8 kilometer. Okay, now let us talk about the subtend angle. Now, although the Sun is very large, although the Sun is large, it subtends an angle of only 0.53 degree or 32 minutes. Okay, now as you all know that Sun is a very large uh, star, and even though it is very large, it subtends an angle of only 0.35 degree. So if this is the Sun, and if I consider this to be Earth, so the subtended angle, so this is the subtended angle, and this is approximately equal to 0.53 degree. Okay, so this angle is known as the subtended angle, which is a very small angle. It is only 0.53. Okay, now the beam radiation received from the Sun on the Earth is also almost parallel. Okay, that the radiation received by the radiation received by the Sun on the Earth is almost, we consider it almost parallel. Okay, it's almost parallel. Okay, now the brightness of the Sun, it varies from the center to its edge. Varies from its center to its edge. Okay, it means that the at the center, at this region, the brightness is high compared to the radiation, or the intensity of the radiation at the its edge. Okay, but for engineering calculation we assume it has a uh, uniform brightness. Okay, but for engineering calculation we assume that the brightness is uniform. Okay, now let us talk about extraterrestrial energy flux. What is extraterrestrial energy flux? Now first of all we need to understand what is extraterrestrial. Now extraterrestrial means anything which is beyond our Earth atmosphere, so that is known as extraterrestrial. beyond Earth's atmosphere is considered as extraterrestrial. So extraterrestrial energy flux means the amount of energy flux which is on the Earth atmosphere, which does not enter the, which have not crossed the Earth atmosphere, but the flux energy which is on the Earth atmosphere. Okay, so it means the energy flux. Now, since it is a flux, the unit is watt per meter square. Okay, so the energy flux from the sun outside the Earth's atmosphere. Okay, these energy flux did not enter the Earth's atmosphere. They are on the Earth atmosphere. Okay, so it means if I consider this to be Earth, and these dotted lines are the Earth atmosphere, so the radiation received by the Earth atmosphere. Okay, so that is known as extraterrestrial energy flux. These radiation did not cross the Earth's atmosphere. Okay, so if you are familiar with the extraterrestrial energy flux, now let us move forward. Now let us define the solar constant. What is solar constant? Now, first of all, solar constant. The concept of solar constant is it is very similar to the extraterrestrial energy flux. So, solar constant is the radiation energy received from the sun on a unit area perpendicular to the rays of the sun at a mean distance of Earth from the sun. Okay. So, first of all, let me explain it. So, let me first write it. It is the energy rate received from the sun on a unit area perpendicular to the rays of the sun at a mean distance of the Earth from the sun. Now, from the definition, what does it mean? Let us suppose this is the sun, and this is the Earth. So, solar constant is the amount of energy received from the sun. Okay, so it is the amount of energy received from the sun on a unit area. So, first of all, we have to consider a unit area on the Earth. So, suppose this red dot is the unit area. Okay, meter square. So it is the energy rate received from the sun. First of all, it is a energy rate. Energy rate means watt or joules per second. So it is the energy rate received from the sun on a unit area perpendicular to the rays of the sun. Okay. So what does the perpendicular to the ray of the sun means? It means that these rays are perpendicular. Okay. So they makes an angle of 90 degree with the area or the unit area that we are considering. Okay. At a mean distance of the earth from the sun. So this distance has to be the mean distance. Okay, this is mean distance, and we already know this mean distance is equal to 1.496 into 10 to the power 8 kilometer. Okay, so first of all, the value of solar constant it is calculated for a unit area. Okay, and at a mean distance. Okay, now the difference between the solar constant and extraterrestrial energy flux is that the extraterrestrial energy flux is calculated on the basis of the distance between the sun and the earth. Okay, and solar constant is calculated on the basis of the mean distance between the between sun and the earth. So if I consider ISC, this is equal to the solar constant. So that's why it has a term known as solar constant. And ISC dash, it means extraterrestrial solar radiation. Okay. Now ISC, solar constant. Now this is a constant value and it is calculated on the basis of the mean distance between the sun and the earth. Okay. But extraterrestrial solar constant, it is calculated on the basis of the distance between the sun and earth. Okay. Now ISC, that is solar constant, it is a constant value because it is calculated on the basis of mean distance. But extraterrestrial solar radiation, it is calculated on the basis of the distance between the sun and the earth. And we know that the distance between the sun and the earth is not constant. Okay, as we have already discussed, the sun moves around the earth moves around the sun in an elliptical orbit, and the distance between the sun and the earth changes on which depends on the day on the earth. Okay, so that's why this ISC value is not a constant value. Okay, its value changes, and that value depends on the day on the earth, and it depends on the day on earth. Now, first of all, what does day on earth means? It means that 1st of January is considered as the first day on the earth. 2nd of January is considered as the second day on the earth. Okay, and similarly, 31st December is considered as 365th day on the earth. Okay, now since the value of solar constant is a constant value, now many research work has been done to calculate this value. So 1367 watt per meter square is the standard value of the solar constant, and do remember this value. This value is important. Okay, but the value of ISC dash, as we have already discussed, this is not a constant value. The value changes with respect to the day on the earth. So there has to be a formula. Yes, there is a formula to calculate this. So ISC dash, it is equal to ISC 1 plus 0.033 cos 360n by 365. Okay, now where this n, this small n is the, it is the day on earth. Okay, and do keep in mind that this value 360n by 365, this value is in degree. Okay, now ISC we have already discussed, this is 1367 watt per meter square. The unit of extraterrestrial solar constant is same as the unit of the unit of extraterrestrial solar radiation. It is same as the unit of the solar constant, which is watt per meter square. Okay, now let us talk about this cos 360n by 365. Now first of all, we know that the value of cos, according to the mathematics, the value of cos changes from positive 1 to negative 1 value. Okay, and so we can say that therefore the ISC dash varies by plus minus 3.3% over the year. Okay, now what does it mean? And let us suppose the value of cos theta is plus 1. So this value is positive. So 1 plus 0.033. So that's why plus 3.3%. And if the value of cos theta is minus 1, there will be a negative sign. This becomes 1 minus 0.033. So this is a negative 3.3%. Okay. So do remember, first of all, this cos theta, it is in degree. And we already know that the value of cos changes from positive 1 to negative 1. So therefore, the extraterrestrial solar radiation, it varies by plus minus 3.3% over the year. Okay. Now let us try to draw a graph between uh, extraterrestrial solar radiation and the day on the earth. Okay. So what I'm trying to draw a graph between ISC dash versus the day on earth. So this axis is ISC dash and this axis is the day on earth. So this is 1 and this represents uh, January 1st and this is 365. This is a December 31st. Now if I put the value of n here, n equal to 1, so cos 360 by 365, okay, which is approximately equal to cos of 1. Okay, so cos of 1 degree, or if I consider cos of 0 degree, that is approximately equal to 1. Cos 0 is 1, we know that. So what I'm saying that cos 360 by 365, this is approximately equal to 1 degree. No, sorry, this is approximately equal to cos of 1 degree. Okay, and we know that cos of 0 degree is 1. So I'm considering cos of 1 degree equal to 1. Okay, because 0 degree and 1 degree, they are very close to each other. So at this point, if I put the value of 1 here, so this becomes 1.033 and in multiplied by 1367. So I get the value of ISC dash for January 1st. Okay, so this comes out to be approximately equal to 1410. Okay, if you want to cross check, you can calculate this value by putting the value of n equal to 1. Okay, and as n increases, this value decreases and it hits the bottomless value and it again increases up to this value 1410 again, which is 31st December. Now the lowest value is approximately at 120th day or 183, which is July of 1st or 2nd. So at that time, the value of ISC dash is minimum, and this line represents the mean value, okay, or ISC, which is known as the solar constant, 1367, and this value here, this is approximately 1320. Okay, now if you want to cross check, you can put the value of you can put the value of n equal to 1, n equal to 182, and n equal to 365. You will get these these two results. Okay, so if you want to practice, you can draw your graph on your own or you can check it online. Okay, so thank you for today's lecture and we'll see you in the next lecture.